The graph of WKX, which is the modulus of k over 2 mod x minus k take away k, is called a W graph where k is a positive constant. The graphs of y equals w2 of x and g of x is x minus 2 take away 2 as shown below for k equals 2. The dashed one is the g of x and the solid one is the y equals w2 of x, and they are the same along those two limbs just there. Let's have a quick look at this. So this would be y equals the modulus of 2 over 2, which is just 1. So it would be mod x minus 2 take away 2. That's why we've drawn that one on the modulus, and that's why it just bounces up in the middle here. And we can try a few values here. So when x equals 2, we just get mod negative 2, which is equal to 2, which is how we get this point here. When we have x equal to 0, it would be modulus of negative 2 take away 2, so that's 0. And when we have 4, it would be mod 4 minus 2, which is 2, take away 2, which is 0, which is how we get these two intercepts. So on the axes below, we want to sketch y equals w3 of x, i.e. the W graph for k equals 3, which they've stated here, w3 of x is 3 over 2 mod x minus 3 take away 3. So we can see the bounce is going to happen when x is 3. So let's just do w3 of 3, and then that is going to be 3 over 2 mod 3 minus 3 take away 3. So all of that bit is 0, so it's mod negative 3, which is 3. So we've got 3, 3 just there as being the peak of the graph. Now the next value I'm going to try is w3 of 1. So that will be 3 over 2 mod 1 take away 3 take away 3. So this bit becomes 2, which cancels with that. So we've got 3 take away 3, which is 0. So that's going to be 0 there. And the symmetry of this tells us the same thing's going to happen with 5. So that would be just there. What about w3 of 0 to get the y-intercept? Well, that's going to be 3 over 2 mod negative 3 take away 3. So that is going to be 9 over 2 take away 6 over 2, which is 3 over 2. So the y-intercept will be there, symmetry means that will be there, and we can probably draw the graph from there, like so. So it's going to look something like that. Well, we've got a spare grid if we need it. Determine how many solutions the equation WKX equals K will have and justify your answer. I think from what we've seen, we can see there's going to be 3 solutions. Just for example here, we would be putting 3 on there, and we've got 3 solutions, one over here, and where it hits the peak. And the same was true if we had w2 of x equals 2, would give us a, sorry, not there, that's the y-intercept. Solution there, not a solution here. Let's try and get rid of that. And a solution over there. So I think it's 3 solutions, and I would draw a picture to show the three solutions. And that should be enough for the 2 marks. By considering the general W graph, develop an expression for the interval from k minus 2 to k plus 2 of wk of x dx in terms of the constant k. I don't think this is going to be too bad. This is just going to be a triangle. If we think about how I did the values above, so the peak is going to happen at k. And in fact, it should be at kk. And these are going to happen at k minus 2 and k plus 2. Just go back and investigate with the 2 case and the 3 case, and you'll see that's true. And so we've got a height of k and a base of 4. And so the area is just going to be a half times the base times the height, and that is just going to be 2k.